Learned, or the week before last rather, we learned a method for graphing involving the table. So we're going to learn a different method today called the intercepts method. And the intercepts method involves finding where the graph, or where a graph crosses the y-axis, meaning where it intercepts the y-axis, and finding where a graph crosses the x-axis, or where it intercepts the x-axis. This is a much faster method for graphing, and you're going to learn several methods, another one later on this week, but this is a really good one to have in your back pocket. So let's first do some definitions. And for the y-intercept, who can tell me that for any graph, where the graph crosses the y-axis, what's the value of x? The value of x for where the graph crosses the y-axis. Lydia? 0. Perfect, it's 0. We also need to keep in mind for the x-intercept that the value of y would then also be, John?
0.
0. So, for example, let's look at this graph here. You can just look at it because we've been provided with the graph. Who could tell me what the x-intercept is? Amia?
It is 5.
5. And the y-intercept is, Eugenie? 2. Now, that's great. We could tell that because we had the graph. But we also need to be able to do it algebraically. So, to do it algebraically, you're going to first start with letting x be 0. And if x is 0, that will end up giving us the place where the graph crosses the y-axis. So 2 times 0 plus 5 times y, we're going to plug it in and solve for y. That gives me 5y is 10. Divide each side by 5, and y is 2. The next thing I want you to do when you're using the intercepts method is to write this y-intercept as a coordinate. If x is 0 and y is 2, how do we write that as an x comma y coordinate? Yes, Annie?
0, 2.
Good, 0, 2 in parentheses. Thank you. Go ahead and draw a line. I kind of like doing that. And let's go ahead now and find the other intercept. So we're going to let y equal 0. So we'd have 2x plus 5 times 0 equals 10. 2x is 10, and x is 5. Last step is to write it as a coordinate, 5, 0. And notice we got exactly what we got from the graph. But the ability to solve it algebraically will enable you to provide your own graph. So now let's look at the next one. As you'll learn in geometry, if you haven't learned already, if you have any 2 points, you have a line. So all we need to do to graph a line really is get 2 points, and these 2 intercepts will be our 2 points. So we're going to start with exactly the same method we did before. So we're going to say let x equal 0. 3.5 times 0 plus 7y equals 14. Obviously 3.5 times 0 goes away, and I end up with 7y equals 14. And y is 2. The next thing I want you to do is write it as a coordinate. Benji, could you tell me what this coordinate would be?
0, 2.
Nice. And I draw the line. And now I say let y equal 0. 3.5x plus 7 times 0 equals 14. Obviously the 7 times 0 goes away. And then left with 3.5x equals 14. Yes, Matt.
Is that 4?
It is 4. You can say if there are 2 3.5s and a 7 and 2 7s and 14, 2 times 2 is 4. Or you could write 3.5 as a fraction, 3 and 1/2, and then write that as an improper fraction, multiply each side by the reciprocal. Write it as a coordinate. Now we're going to take each of the coordinates and graph them on our coordinate plane. So we're going to plot 0, 2, right there, and 4, 0. We have 2 points. Grab your straight edge and connect the dots. Any 2 points is a line. That method is faster, believe it or not, than the table, and especially as you get quicker on plugging it in 0, it becomes much faster. Any questions so far? Yes, Jake?
You can't do that for parabola.
No. This is for linear equations. Good question. All right, so let's go to the next one. Start the same thing. Let x equal 0. If x equals 0, then I'd have y equals 4 times 0 minus 3. The 4 times 0 would go away, and 0 minus 3 rather is negative 3. Write that as a coordinate. And find the x-intercept. Let y equal 0. It's kind of opposites. When you're finding the x-intercept, you let y equal 0. When you're finding the y-intercept, you let x equal 0. So if y is 0, I'd have 0 equals 4x minus 3. We have a little more manipulation to do with this one. Miles, what is my first step?
The first step is to make you make y equals 4x. And 0 equals 4x.
Minus 3, which I have. So what do I want to do next?
Now you make 4x equals 3.
So you're going to add 3 to each side. Good. So that would be 3 equals 4x. Then go ahead and divide out the 4. And we get that the x-intercept is 3/4. Write that as a coordinate. Now we're going to take each of our intercepts and graph them. So 0, down 3, put that dot. And for 3/4 comma 0, don't panic about it being exact. Just try and put your dot somewhere between 0 and 1, preferably closer to 1. Take your straight edge, connect the dots, and make sure your line, extends across the graph, the entire graph. Okay? Any questions so far? All right, nice job. Let's keep on going. Now, in part C, you could choose to simplify this first, but you do not need to. So start by saying let x equal 0. So I'd have negative 2y equals 1/2 0 minus 4. Keep simplifying. 0 minus 4 is negative 4. Multiply 1/2 times negative 4, we get negative 2. Divide by this negative 2 to get our y-intercept of 1. Write that as a coordinate. And draw your line. Now say let y equal 0. So negative 2 times 0, 1/2 parentheses x minus 4. So 2 times 0, or negative 2 times 0 rather, is 0. I'm going to go ahead and distribute in this next step at the same time. So simplify that side. So I'd have 1/2 x minus 2. All right, Alessandra, what would be next?
You add 2 to both sides.
Add 2 to both sides. Nice. And Sophie, what should I do next?
You divide both sides. Oh, you can multiply by 2 over 1.
Yes, multiply each side by the reciprocal, which would be 2 over 1. Good. We get x equals 4. Write that as a coordinate and get ready to plot your points. So I'd have 0, 1 and 4, 0. Grab that straight edge and connect your dots. Quick graphs. Now this last problem is a word problem, and oftentimes for word problems, using the intercepts method will be the best way of graphing. I'm going to teach you another method later on in the week that you'll end up wanting to use all the time, but for word problems, remember this. The intercepts method is always going to be a little easier. So in this problem, we're not actually going to find a definitive answer. We're going to make a model that will be able to generate possibilities. Okay? So it says Palm Desert Middle School organizes a dinner to raise money for their school band to travel to Pasadena to participate in the Rose Bowl parade. How nice for them. Their goal is to raise $1,500, and they're going to sell tickets to do that. Assuming 200 adults and 100 students will attend the dinner, how much should be charged for an adult ticket and for a student ticket? So the problem is going to walk us through. It first wants us to define our variables. I'm going to get you started with the first one so that it matches what I have. And I'm going to say X is the cost in dollars for an adult ticket. Ben, what should, we're going to have two variables here. So, Ben, what should be my next variable be?
Cost in dollars of students.
Perfect. And we're going to say let Y equal cost in dollars for student ticket. We have two variables now. Yes?
Would you make the bigger variable x and would be, how did you choose that adults and x?
That's a good question. I just decided that X was going to be adults and Y was going to be kids. But technically it's right the other way. But try to do it this way just so that your notes will match mine. So now we know that 200, we're assuming 200 adults will come and that 100 students will come. And we want to generate $1,500 from this event. How can I write an equation that will describe the situation? Logan. Perfect. Perfect. 200x plus 100 for every y will hopefully get us $1,500. The next part says to use the intercepts method to graph the equation. So just like we did before, we're going to say let x equal 0, plug in 0 for x, and solve for y. Obviously dividing each side by 100, we get y is 15. Write that as a coordinate. And move on. Let y equal 0. $100 times 0 goes away. We're left with 200x equals 1,500. Divide out the 200. 15 over 2 is 7.5. And write that as a coordinate. Now, the last part just wants us to graph the equation. So go ahead, I'm going to plug in, or plot rather, 0, 15, and 7.5, 0. So for 7.5, I'm just going to put that right in between 7 and 8. Grab your straight edge to connect the dots. Whoa, that's not exact. I'm going to try again. It's a bit better. Now in this problem, it didn't ask us in these parts here for a solution, but it did mention in the words here how much should be charged for an adult ticket and a student ticket. And the answer is that there's no definitive answer, because any point along this line would satisfy our equation and would allow them to raise $1,500 given the assumption that 200 adults and 100 kids come. So since any point can work, let's pick a sample one. Look at your line and give me an XY coordinate that's on the line. Jake.
Well, it could be 0, or no, it could be like the y-axis could be, or it could be 7 and 4.
7, 4. I don't see, if I go over 7 and up 4.
4, 7.
Okay, so 4, 7. That looks like it's on there. And we can test it just to make sure. And say 200 times 4 plus 100 times 7. Does that equal 1,500? And you may not actually get one that works because maybe our line's a little off, but let's see. So that becomes 800 plus 700. Yes, that works out to be 1,500, so that's definitely a possibility. Good. Logan, can you give me another possibility? That would work. We could charge the adults and kids the same. 5, 5 is here. 5, 5 definitely works. 200 times 5 plus 100 times 5 equals 1,500. The kids in the class before me always wanted to charge the adults more because they figured they had more money. So they like this one, 7, 1. Charge the adults $7 and charge the kids only $1. It works. So now the question that I would have, or that I actually got in my first class is, well, what if this was on a test? What would be the right answer? Well, first of all, I would be a little more explicit in the directions, and that they'd say something like, give me a possible combination of tickets or ticket prices. And then as long as you showed this type of work where you provided a point that was on the line, plugged it in and showed me that it worked, then you'd get credit. All right? Good job.